In this video, we're going to create an app that predicts whether someone is qualified or not qualified from a loan. So let's import the necessary libraries. MP, let's import Cbon. Let's import train test split, sklearn dot model selection, import train test split from sklearn. We're gonna import our support vector machine from sklearn metrics, sklearn dot metrics. I'm gonna import accuracy score, and I don't want any warnings, so I'm gonna do something about that. So import warnings, and warnings dot filter warnings we're gonna ignore. Let's run this cell, and I saw the mistake here. It's warning it at S. Let's run this cell, and now we have no mistakes. So the next thing we have to do is load the data in a data frame. So let me just write a note. Loading the data set into pandas data frame. So we set LD. Gonna set the variable LD for loan data. pd.read_csv. The name of our file is loandata.csv. Let's look at the first 8 rows of our data frame, and you see we loaded our data frame. If you're writing it like this, then the CSV should be in the same folder as the Jupyter notebook file that you're working on. So next, let's check in for null values. We have to do some data manipulation. So LD is null. And let's see the sum of all the null values. And you see we have a bunch of null values. But before we move into this, as you can see, we have this 3+ here. And this won't work well when we put it into our support vector machine. So we need to change this to either an integer or a decimal. So let me just see the value counts of all the values in the dependence column. Let's run that. And you see we have 51 of this 3+. So let's replace this 3+ to 4. So set LD equals LD.replace. We want to replace 3+, and we want to give it the value of 4. So let me copy this. CV. Let's run this cell, and you see it has been changed. So next, let's tackle on the missing values. Just to save time, I'm just going to drop all the missing values. LD equals LD.drop, the drop NA function. And let me just copy this. And you see we don't have any more null values in our data frame. The next thing we need to do to our data frame is the loan status, where we need to predict, based on all these columns, we need to predict whether someone is qualified for a loan or not. But we can't put these Y's and N's into our model. It needs to be 1s and 0s. So we're going to change the Y into 1 and the N into 0. So let's do that. So we're gonna do LD.replace and the loan status column. It should be in between quotes. And we want to change the N to 0 and the Y's to 1. Then we have to set the in place to true, so the changes stays in our data frame. So let's take a look at the first 8 rows. And you see it has been changed. Now let's change the rest of the categorical columns into numerical values like the gender, education, married, the property area. I think it's only these 5. So first let me see all the unique values in each of these columns. So I'm gonna print married. Now this should be in between block brackets. LD. And we want the unique values. Let me just copy this. Control C. And let's change this to gender. This to the self-employed column. This to the property area. And finally the education column. Oops. Let's run that cell. And you see we got each of the unique values. So now let's convert these into numbers. So I'm gonna set LD to replace. First I'm gonna do the married column. And we set the no's to 0 and yes to 1. Put a comma here. And the next column is gender. Then we set the male to 1, the female to 0. Then we do the self-employed column. Set the no to 0 and the yes to 1. Next is the property area. Set the role to 0 and then set the semi-urban to 1 and then urban to 2. And lastly, our education column. Set graduate 1 and not graduate to 0. Then we set the in place to true so the changes stay in our data frame. And now let's take a look at our data frame. And you see we change all the categorical values to numerical values. Next, let's separate the labels and features. Let me write a note. And we're gonna put the features into X, and we want everything in the data frame except the loan ID column. And also our label column, which is the loan status. Control V to paste this here. And then we want to set the axis to 1 since we're dropping rows. I mean, since we're dropping columns. If we were dropping rows, we would set the axis to 0. Now our Y, we want the loan status column. So let's take a look at our X. And you see it has the data frame except the loan status column and loan ID column, and our Y. It will be a series because it's one column. And that has all the values in our loan status column. So now let's split our data into training and test sets. So to do this, let's write X train, X test, Y train, Y test, and we set that equals to train, test, split, and the arguments it takes is our X and Y. Then we set the test size to 10%, so we put 0.1. And next we want to stratify Y. And what this means, we want the ones and zeros to be split proportionately. We don't want all the zeros in the tests and all the ones in the Ys. I mean, we don't want all the zeros in the train and all the ones in the test. So when we stratify Y, it's going to split proportionately. And that next we set the random state to 2. And this prevents our data from reshuffling every time. If you're following along and you set your random state to 2, your data will be split the same way as mine. So next, let's look at the shapes. So the X shape, the X train shape, and then the Y train shape. And let's run that. And you see our X shape is 480. Our X train shape is 90%, and the Y train, no, we're supposed to get the Y test, not the Y train. Let's run that. And you see the Y test has 10% of our data, and the X train has the other 90%. Actually, it's the X test. Let's run that. So the X test has 48 rows, 11 columns, which is 10% of the data frame. And the X train has 90% of the data frame. And this is the X shape before we split it into train and test. So now let's initialize our model. CLF equals SVM dot SVC. And let's set the kernel to linear. And let's run that. Oh, I misspelled kernel. Let's run that. And everything is fine. So now let's train the support vector machine. So we set our classifier dot fit. And we want to fit the X train and Y train. Let's run that. So now that we trained our support vector machine, let's do some model evaluation. And first I'm gonna check the accuracy score on the test data. I mean on the train data. I'll also do the accuracy score on the test data, but I want to check for overfitting or underfitting. So I'm gonna set the variable X train prediction equals CLF dot the predict function, and set the X train. Then I want to set the training data accuracy. I set that equals to the accuracy score. X train predict, and the actual values in the Y train. So now I want to print accuracy score on training data. And then I'm gonna copy and paste this. Let me just retype it. Training data accuracy. And let me copy this. Control C. Next, I'm just gonna copy all of this. Control C, paste, and change all the train to test so we get the accuracy score on the test data. Set all the trainings to tests. Now let's run that. Oh, it's not prediction, it's predict. And you see we have accuracy score on the training data is 79 and the accuracy score on the test data is 83. And these are close range, so there's no underfitting or overfitting. There's some other metrics we can use to determine how well our model is doing. So from sklearn.metrics, I'm gonna import precision score, the recall score, and F1 score. I'll explain what each of these mean. So I'm gonna create this variable, precision score, and we want the X-test prediction from here, and then the Y-test. Just to note, you should only check the accuracy score on your test. This determines how well your model is doing. But I wanted to do the train just to make sure that there's no underfitting and overfitting. So let me just copy this. And REC for the recall score. Paste this. And F1 for the F1 score. And then paste this. Then I want to print all of them. So precision equals our precision variable. Then I want to print recall. We put our REC variable. Then I want to print F1. And we're gonna put our F1 variable. Now let's run that. And you see we got a precision score of 93, recall of 83, and F1 of 88. So the precision score answered the questions out of all the loans that the model predicted as yes, qualified or approved. How many were actually qualified? A precision score of 93 would mean that when the model predicts a loan as qualified or positive, it is right 93% of the time. The recall answers the questions out of all the loans that should have been approved. How many did the model correctly identify as approved? If the recall score is 83%, it means the model correctly identified 83% of the loans that should have been approved out of the total number of loans that were actually approved. And the F1 score, it could be understood as the harmonic mean of the precision score and the recall. It answers the questions: how well does the model perform in terms of both precision and recall score? So now let's go ahead and start making predictions. So we're gonna have our inputs and set that equals to, and we're gonna come back to this. And the next thing we have to do is when we put our inputs, we need to change the input data into a NumPy array and reshape. So let me type input as np array, and put np array. We put our inputs, and then we want to reshape it to one row of values, and then we're going to set the column side to -1, and the -1, it automatically detects the amount of columns. So now let's set the prediction to equal CLF, which is our model dot predict, and we want to predict our inputs as np array. And then let's print prediction. And then I want to create a little if and else statement. So if prediction, and we want the first value, and if it equals 0, which is no, we're gonna print this person should not get a loan. Else print this person is qualified for a loan. So I want to scroll up and concatenate. I want to get the test data set after our train test split. Where is it? So let me add a cell here. So I want to save it as a CSV and open it as a notepad. So pd.concat x test y test, set the axis to 1. So I'm adding the y test series to the x test data frame along the columns, and let's take a look at that. Let me just look at the top 5. So run that, and you see we have the test data frame, and what I want to do is save that as a CSV file. So we do this df.to_CSV, and we want to call it test.csv. This should be in quotes, and we don't want an index, so we set the index to false. Now let's run that, and if we look into the folder, we see that we created a test CSV, and I want to change this into open with Notepad, so I have all the test data sets. So let me go back to our predictions. So now let's make some predictions with the test data, and let's try this first one right here, and it should come back as a 1, which means that this person is qualified for a loan. So let me copy this, Control-C, and paste it here. And let's press Shift and Enter to run this cell. And as you can see, it says this person qualifies for a loan. Let's try this one right here. And it should say the same thing. Control C, Control V to paste, Shift and run. And this person qualifies for a loan. Let's go down at the bottom. And let's take this one. I'm just taking them randomly. Control C to copy. Control V to paste. And it should say that this person should not get a loan because the loan status column here is 0. So let's run this cell. And as you can see, it said this person should not get a loan. Let's do one more example. Let's do this one. Let's press Control C. Come over here. Control V to paste. Let's press Shift and Enter. And you see that, yes, it was correct. Not all of these are gonna be right because our accuracy score stated that it will get 83% right. Or our model has an accuracy score of 83%. So the next thing we have to do is save our model. So let me write a note, saving our model. And to do this, we have to import joblib. And then we use our joblib.dump. And we're dumping our classifier model. And we want to name it CLF model. And we have to give it the PKL extension. So now let's run this cell. And you see it was created. And if you go into our folder where it created our Jupyter notebook, you see that our model was saved in that folder. So now let's move on to creating the user interface for our application. And we're gonna use Sublime Text for this. And now let's open the folder that we have our Jupyter notebook. So it's on the desktop and the folder name is YouTube. And let's select this folder. And you see we have our model, our CSV, and our untitled Jupyter file. So let's create a new file. And let's call it loanapp.py. And make sure it's saved into the folder. YouTube, save. So the libraries we're gonna need in this file is NumPy, gonna import Streamlit as st. Then we're gonna import joblib so we can open our save model. So the first thing we're gonna do is load the model. So let's create a variable called model, joblib.load, and we need to put the file path of our model. So let's go in our folder, desktop, YouTube, and let's copy this, and let's paste it here. Let me give a / just because it's showing something funny. And then / the name of our model and the extension. Next, we need to create a function. We're gonna call it loan prediction. We're gonna put the inputs here. So, and we're doing the same thing we did here in the Jupyter file. Well, let me just copy and paste it. And everything needs to be in line. And instead of print, this should be return. remove this bracket, return. Let's remove this bracket, and let's define the main of our app. So let's main. Let's giving a title. So streamlit.title, and we want to call it a loan status prediction app. And next we want to get the input from the user. So getting the input from the user. So gender equals st.text underscore input. Then we want gender. Let's put a placeholder equals male 1, female 0. Let me just copy this. 4, 5, 6, 9, 10, 11. And then we want gender. Next we want married. And the placeholder will be no 0. Yes is 1. Dependence. We don't need a placeholder for her. Education. And the placeholder is graduate. And not graduate. The next feature is self-employed. And it's the same placeholder. Control C. Next is applicant income. This one doesn't need a placeholder because it's just the income. Next one is co-applicant income. This one also doesn't need a placeholder. Next one is loan amount. And it doesn't need a placeholder. Let me just copy this because the next one is loan amount term. We need a little bit more because there's more features. Credit history. And this one doesn't need a placeholder. And also the loan term amount doesn't need a placeholder. And last is the property area. And the placeholder is rural, is 0, semi-urban, is 1 and urban is 2. Now let's create the code for the prediction. So predict equals, give that empty quotes. And now let's create a button for the prediction. So we want to say if streamlit dot button, and we're gonna give the button some text. Check if this person qualifies. We want to set the predict equals loan prediction function that we created. And then we put a list with all of these here. So gender, married, dependents, education, self-employed, applicant income, co-applicant income. The next one is loan amount, the loan amount term. Credit history and property area. And the next line of code is streamlit success. And then we want the prediction. Lastly, we need to add this last piece of code so our app can work. So if name and 2 underscores equals 2 underscores main, we're gonna call our main function. Let's press Ctrl S to save this. And it looks like everything is done. And if we wanna run this app, we have to call our command and write streamlit run, and in quotes, let me get the file path. And then the name of our app is loanapp.py. Closing quotes, and let's press enter. And then here we have the local URL. So it's showing that we have a mistake on line 17. Let's go back. That's why I didn't want to paste, because of the indentation. Let me just write it over again. So if prediction equals 0, I'm gonna return this person not get a loan. Else return this person is qualified for a loan. Let's press Ctrl S and hopefully that works. Let's reload our app. And it worked. So now let's put in some values. Let's try this one. So the gender is 1, they're married, yes. The dependence is 0, they did not graduate. They're not self-employed. The applicant income is $1,800. The co-applicant's income is $2,934. The loan amount is $93. The loan term amount is $360. The credit history is 0. And the property area is 2 for urban. So let's check if this person qualified. And we have an error. Oh, remember when we copied and we pasted our CLF from Jupyter Notebook. We should be using the model. We saved our model in this variable. So let's press Ctrl C and replace this CLF with model. Ctrl V, let's press Ctrl S. Now let's press this again, and it says this person should not get a loan. And you see here, it's correct. Let's try this one. Let me just refresh this so everything is clear. And it should return that this person should qualify for a loan. So the gender is male, they're married. They don't have any dependents. Their education is that they're graduated. They're not self-employed. The applicant income is $2,333. The co-applicant income is $2,417. The loan amount is $136. The loan amount term is $360. The credit history is 1, and they live in an urban area. So this should return that this person qualifies for a loan. So let's check. And it says that this person qualifies for a loan. Let's do one more example. Let's do this one. Let me refresh. So the gender is male. The applicant is married. 0 dependents, did not graduate. They're not self-employed. The applicant's income is $1,668. The co-applicant income is $3,890. The loan amount is $201. The loan amount term is $360. The credit history is 0. And they live in a semi-urban area. So in the test data, it shows that this person does not qualify for a loan. Let's click our button, and it says that this person should not get a loan. So this is how you create a loan status prediction app.